Hi class, here's another short video about some Pythagorean Theorem application problems. This comes from page 669, number 20. It says the perimeter of the polygonal shape is 126 centimeters. Find AB. Okay, so you know perimeter is the outside of the shape all the way around. The first thing I want you to do, I actually want you to pause this video and count the perimeter, and I'll do the same. Okay, if you started and counted all the way around, there are 14 sides. The question is asking us to find this distance here in blue from A to B, and you can see that this would be the hypotenuse to this right triangle. The first thing we need to do is find the distance of one side of the square. This is where the perimeter comes into hand. If all 14 sides together is 126, we need to do what is 126 divided by 14, and that's 9. So now we know each side is 9, so that makes this distance here at the bottom of that right triangle is 9. And then this distance right here, okay, this longer leg that I'm highlighted in purple, I hope you see that it's 2 sides of a square long, which is 9 plus 9, which gives you a total of 18. Now that we have those two values, we can use the Pythagorean theorem. We will let 9 be A and 18 B, and then of course the hypotenuse is C. So this is 9 squared plus 18 squared equals C squared. This is now 81, and then 18 squared is 324. Then we'll add 324 plus 81, and that's 405. And then the last step is to take the square root of both sides, and so C approximately 20.1 centimeters. And that's your final answer. This one is from page 671. It says a regular hexagon has an apothem of 8.7 centimeters and a perimeter of 60. And then there's two questions. What is the area of the hexagon? And then what is the radius of a hexagon? Before we get started, you need to make sure you know what an apothem is and radius. Apothem is the center of the polygon to the midpoint of the side. Radius is from the center to vertex. A regular hexagon has 6 sides. So the first question is, what is the area of the hexagon? Formula is area equals 1/2 perimeter times apothem. So this one we're just going to plug in some numbers here. We're going to say 1/2 times 60 times 8.7. And when you multiply that together, it's 261 centimeters squared. So that is the area of the hexagon. Question B asks us to find the radius of the hexagon. So for this, I'm going to draw a little picture. So let's say this is one of the sides of the hexagon. If the hexagon has a perimeter of 60 and there's 6 sides, one of those sides must be 10. I'm going to draw the radius here in this red color. The radius is from the center of the shape to the vertex. In blue, I'll draw the apothem we were given was 8.7. But what you need to know about this apothem is that it does split the side into 2 equal parts. And so this smaller part is going to be 5. And now you see the values that we're going to set up for the Pythagorean theorem. We'll say 5 squared plus 8.7 squared equals C squared, which C is our radius. So this is 25 plus 75.69 equals C squared. When you add those two together, it's 100.69. And then we're going to take the square root of both sides. We'll put it over here. C equals 10.03 centimeters. So that is the distance of the radius. All right, we're going to do one more problem on this video. It's really similar to the previous problem, except this time we're working with an octagon, which has 8 sides, and we're given the radius this time instead of the apothem. And then we still have a perimeter. This time the perimeter is 96 centimeters. This one is also from your textbook, page 671, number 42. All right, the first thing we're going to do is asking us to find the apothem of the octagon. So again, I'm going to draw bottom section of an octagon. We'll just work here. We'll say this is the center. Red is the radius, and we'll let this blue be the apothem coming down. And remember, it does meet at the midpoint of the side. All right, and what we do know is we do know that the radius is 15.7. We also know the perimeter is 96. So just a quick division problem, 96 divided by 8, that will tell us the length of one side, which 96 divided by 8 is 12. And so if the whole side is 12, when the apothem comes down and splits it into 2 equal parts, this little part here is a 6. Okay, so now we're going to use Pythagorean theorem to find the distance of the apothem. But I want you to be careful here because the radius, this is still your C, and we can just let the 6 be our A. So we can say 6 squared, we'll call the apothem B squared, equals 15.7 squared. That is 36 plus B squared equals 246.49. I'm going to solve this just like a regular equation by subtracting 36 from both sides to get 210.49 equals B squared. The very last step is to take the square root of both sides, and that leaves us B is approximately 14.51 centimeters. And that's the distance of the apothem. And this last question asks for the area of the octagon. That formula is area equals 1/2 perimeter times apothem. Now that we found the apothem in part A, it's just a matter of plugging and chugging. So we'll do 1/2 times 96 times 14.51, and that equals 696.48 centimeters squared. That is the area of the octagon. That's all for this video, but if you have any more questions, please let me know.